This should be lab 19, but it could also be lab 20. I forgot which one. And this is where we left off. We used other people's videos to get crankshaft out, pistons out, main bearing support. I can't remember exactly what Ford calls it. Main bearing beam. This part right here. So this is where we are on the bare block. So now's our opportunity to view attention to detail. One of the things that I stress with you quite often, as I can remember to. So what I want to look at right now is the bearings, the condition of the bearings, and then get an idea what we might need to do with the crankshaft. We haven't looked at it yet, but the bearings are going to tell us what the crankshaft is going to look like. So the first thing I need to do is get the oil off of the bearings using a paper towel. Now, in a real rebuild, we wouldn't be reusing these bearings, so it doesn't matter whether we touch them. But then when you put new bearings in, you're not supposed to touch them. The small amount of body fluids that we have, acids a little bit, leaves an etched fingerprint in this very soft bearing material. This one is a really good example of things that aren't going well with the crankshaft. Forgot my pointer. So what I'm seeing, I'll zoom in, this bearing looks like it's had termites working on it. This one has some fine lines that run up and down the whole length of it. This one actually looks pretty good. Good. This one has issues, this one has issues. One thing that we also need to notice is what happened to our thrust bearings. So what is a thrust bearing? What does it do? That'll be something for you to think about. And where are they? They're almost always in the middle of the engine, but they don't have to be. But in this engine, they are right here, in this middle main bearing. And let's see how good I am. We'll come back and look at that close-up of the bearings. These don't want to come apart. They should fall off of the block. Let's see about that. Not critical right now. What I want you to see, though, for sure is, yeah, I better not move too much. Close up of this bearing. Looking at this in the laptop, now you can get an idea. You can see really deep grooves right in here. Probably can't see this part here etched in there. Really rough. You can feel all those imperfections with your fingernails, of course. And look closely at the middle one. This is where we were. Second one, this one right here. extra reflective light doesn't help us much. See what I can do about that. But it'll leave it like it is. So we have some grooves in this bearing. It should be perfectly polished. Actually, we have some in this one also. We look real close at it. This is number 4. And the last one looks pretty good. So this is number 5, 4, 3, 2, and 1. 1 has the issues. Now let's turn it over and look at the cylinders. We'll come back to this. Maybe not, depends on, no, we can do this. We can. Let's do the straightness on the block measurement. So what we are supposed to do is measure the straightness of the block through here. Is the block warped in any way? We do that with a machinist straight edge. Comes in a kit that looks like this. Inside the box is a machinist straight edge. Has shiny surface on one side, which would be this one, and a rough powder coated edge on the other side. I've caught students many times using this side. They've never been exposed to it. They don't know. The machined edge is the one that's perfectly flat. The lab assistant told me that once he caught somebody using one of these as a pry bar also. It would make an excellent pry bar, but it ruins it. And then it comes with feeler gauges to measure underneath the gap right here. We're going to put this in here, and then you would measure with these feeler gauges the gap underneath. That's next to impossible for me to do and show you and make a video of it also. Now, one thing to remember, there's a shortcut on this. So they come with these feeler gauges. Your specification is almost always, we haven't done this on cylinder heads, but cylinder heads and the block surface on the front where the cylinder head bolts up is depending on the length, so they allow 2 to 3 thousandths for a 4-cylinder engine, 3 to 4, almost everything for a 6-cylinder inline engine, And so what I'm looking for is the 2000s feeler gauge. And you can see it here. It's like, you can see it flopping around. Now, to get that into a gap of that's 2/1000ths of an inch, it doesn't work. So what I use is a pocket flashlight, and I shine light between the surface that it's sitting on and this machined surface, and look at the opposite side. If you can see light shining through, coming back at you, like that, well, then you've got a gap. And it is going to need, so what you're trying to decide is, do I need to machine this to get it true again? In this case, it's called a line boring, where they put the mains on and then they run a big boring bar down through all the way and get all of these straight again. Now, if the block's already twisted, what do the cylinders look like, and what does the top of the block look like if the bottom is twisted? What do you think about the top? I'll leave that for you to answer. So this is what's used on cylinder heads also. So it probably won't cover that. But I might, when we get to the cylinder head, putting the cylinder head back on and checking out. And this way it's going to show the other minute. They would show measuring it across the top of each cylinder. Seems to be a waste of time, I would think, but my opinion, I wouldn't do it. I'd measure those three that I just showed you. So that's how we measure the trueness of the top of the block. Next we need to peek in